So we're going to do a little bit more of composing today, like we did yesterday, except this time we're going to go just a step further. Now, to reiterate what we did yesterday, we took a value, we plugged it into one of the functions, and we took that result and plugged it into the other function. That's what this is referring to. This is your composition. So what that looked like was taking the 5 and plugging it in to f of 5. So we have 5 squared minus 3, and then that result was 25 minus 3 is 22. So we had a result of 22. And then that value became the input into g of x. So that g of 22 was 3 times 22 plus 1, or 66 plus 1 is 67. So our result for g of f of 5 was 67. That's your composition. Now, that wasn't difficult, but let's say we needed to find multiple results. So we didn't need to just find g of f of 5. Let's say we needed to find g of f of 8, g of f of 10, etc. Just keep going. That's a lot of work to plug it into one and take that answer and plug it into another. So it would be a lot easier just to compose the functions themselves. Then you'd have one equation, and you'd only have to input the value into one of the equations instead of both. This is what it would look like. So we are going to compose these two functions, g of f of x, which means we are going to take this part, this expression, and this will be the input for g of x. This will be the input for g of x. Okay, so all of this, x squared minus 3, will replace the x in the other equation. So this is what it would look like. 3 times, instead of x, it would be x squared minus 3 plus 1. So we have the original equation, or the original expression, but instead of x, we input the expression from our other function in here. And then our result would be 3x squared minus 9 plus 1, or 3x squared minus 8. Now, this is the composition function. That result is g of f of x, or g in composition with f of x. So we have this function rule now, 3x squared minus 8, and this is what we can use to input values and get our results instead of using both equations. So right here, note, use this to find specific values. Okay, so how we did it up here, this was step 1, basically. We went and got our result, and then step 2, we replaced it into the other. All right, now what we have to do is just plug in g of f of 5 into this rule, 3 times 5 to the second minus 8, and we get 5 squared is 25 times 3 is 75, and 75 minus 8 is 67. So either way we do it, this way or compose the functions and then plug it in, we get the same result. But a lot of times we'll compose two functions together just to save us a step of having to plug in a value into each different function rule, especially if we had to find multiple different solutions. All right, so let's practice this. Let's look here at number 1, and this is on your notes. This is number 1 on your notes. All right, what we're doing is we're composing g of h of x. Now, remember, you start with the inside. H of x is going to be our input, so we're taking 2x plus 4, and it is the input for g of x. It's the input for g of x, so it's going to be replacing this x value right here. All right, so what we have is g of h of x equals, and I want you to look, this is going to replace that x. So we have the whole thing in parentheses, 2x plus 4. 2x plus 4 is going in. That's our input. And then we just finish out the equation, minus 4. All right. Then you can simplify that. You've got 2x plus 4. We don't distribute because this is a separate term. We're subtracting 4. We're still subtracting 4, and those 4's will cancel, so you'll end up with the result of just 2x. So 2x is the result of composing these two functions together. So g of h of x is equal to 2x. All right, let's look at this one. Here we have f of g of t. We're going to start right here. This is our input. Okay, so 3t squared minus 1. That's going to be our input in for this t value right here. So what we have is f of g of t is equal to, I'm going to put my parenthesis there, this is my t. This is what I'm plugging in for that t. And I'm going to finish out the expression, plus 5. So my plug-in is 3t squared minus 1. Finish solving this. Simplifying, 3t squared minus 1 plus 5 will give us 3t squared plus 4. And this is your composition, f of g of t. Let's do just a couple more just for practice to make sure you've got it. Now, the only thing different here is the way this is written. This is still g and composed with h of n. So this is still our input right here, working in the middle. So we're going to acknowledge that as our input. So n squared plus n replaces the n in the previous equation. So g composed with h of n equals 3 times, and instead of that n, we replace it with the n squared plus n. Now in this case, we do need to distribute the 3 to both terms, so we have 3n squared plus 3n. And this is your composition. I just don't feel like rewriting it down. We've got it though. All right. And this, of course, was number 11 on the notes. All right. Just number 11 on the notes. On the worksheet. That's what I meant to say. On the worksheet. This is number 9 on the worksheet. And this is number 15 on the worksheet. All right. So this last example, again, f of a, this is our input. So a cubed minus 1 replaces the a in the first function rule. So g of f of a is equal to, we got to write down a -3. And where we see that a, I'm just going to put a big set of parentheses and then finish off with +4. So now I know right where I need to replace the variable with a to the third -1. Then you're going to just finish that off by distributing the -3. Got a +3 here, and then a +4, and then combine your like terms. So you have -3a to the third +7. And this is your composition of the two functions here. And you're going to continue, this is all you're doing on your assignment. You do have a couple of spiral problems where you need to factor, but you're just plugging in one expression into the variable of the other expression. But it matters, the order matters, so pay attention. You always work from the inside out.